Okay, to take off from where I left off last time, this is the Gecko G540, and there's the strip of inputs and outputs for that. Up here is a breakout board for a parallel port, the second port. Back in the back here, you can see there's a green screw header. That's for a serial port, and that's for outputs from the relays to go to things, the air solenoid and the water pump that cools the motor. So that kind of wraps up the inside of the case. Thought I'd show what we've got here in the back. This is the Gecko 540. These are the DB9 connectors that go to the stepper motors. This is the parallel port that comes from the computer into the Gecko drive. This is the parallel port connector, comes from the computer into that second parallel port breakout board. Kind of a nice little cutout for the fan, the cooling fan. And I kind of led you astray on the outside. That other green connector, it wasn't for outputs. That kind of confused myself. It was from the I've got an auxiliary input type of connector here, so I can what's hooked in there now is the limit switches, and there's more pins on there I can use, and that's just a way to get limit switches, homing switches, things like that are going to be inputs, to get them to go through the case instead of having to run the wires directly through. Just run them the connector, and then from that breakout board into whatever control thing it needs to be. And then the output is one of these DIN connectors that screws on real nice and secure, so that turned out pretty nice. So on the back here, that output from the DIN connector will go, here's the little air solenoid. It's a nice little unit, pretty tidy. One of those little bitty, I think this is just a little Harbor Freight regulator. It works fine for the purposes here. And here's the water pump. So there's 12 volts going to that. It cools off the motor. And incidentally, I've got that connected so when the motor turns on, the pump starts. And when the motor turns off, the pump stops. And so far, that's been showing fine. I've had it running for an hour at a time. And just doing that, it doesn't need to cool past the time when the motor is off. It seems to be nice and cool just having this little system here. I've got a little 3D printed box here. I'm kind of toying with the idea of having a little bit more controls. I've got more inputs I can use, so I was thinking about having like a cycle start, a feed hold, and a stop switch. And then here I will have maybe some feed rate overrides. This will enable it, and the LED will come on. And of course disable it, which will be setting everything back to 100%. But if you want the feed rate or the spindle speed override, you can choose feed rate override with one of them, spindle speed override with the other, and enable and disable. That's kind of what I'm thinking so far. So it's just some switches in a box right now, but that probably go on the front here to cover that hole. It's good for covering mistakes. So here in Mach 3, I've loaded a little program that is just milling a little pocket. Pretty shallow steps. It was made for an 1/8 inch end mill, and it just makes a little pocket. I'm not going to do any actual milling here, but I just wanted to show the machine in motion. So it's all zeroed out as it sits there. I will start it. First thing we'll see is a tool change probably. Nope, just started, so